Probability, the multiplication rule. So the multiplication rule for probability is broken into two types. There's the multiplication rule for independent events. So these are events that don't affect each other. So you do one event and it has no difference on the next. And for dependent events, it matters what happens the first time. And this often happens with something called replacement and without replacement. So we're going to look at an example which I think will make these two concepts kind of a little bit more real. Let's say we have a sack of marbles. So here's my sack of marbles, and you see that I have 4 black marbles, 2 red marbles, and that's a total of 6 marbles. Okay, so let's look at an example where we're going to use the multiplication rule for independent event. For a lot of these choosing, marbles out of a bag or people out of a group, we say that this is with. And that'll make more sense as we go through the example. So in this case, let's look at the probability of me choosing a black and then a red marble. And so this is considered one event, but kind of what happens in real life is first you choose a black, and second you choose red. And like I have titled up here, we're going to do this with replacement. Great, so let's follow our rule here. So we go up here and we say, oh, okay, this is an independent event. Why? Because they told me it's with replacement. So if you ever see the keywords with replacement, you know these are independent. And I think that concept of independence will make more sense as we do this problem. So I just go up to my formula and I say, okay, this is an independent event. It's the probability of the first times the second. So, okay, it's the probability of getting a black marble times the probability of getting a red marble. Alright, so let's fill those in. What's the probability of getting a black? So I look at my sack of marbles and I say, okay, well, how many black marbles are there? 1, 2, 3, 4. How many marbles are there total? 6. So it's 6. It's 4 out of 6. You can reduce this, but I'm just going to keep them the same to just make it simple. And we can change it to a decimal anyway. Great. Let's look at the probability of getting a red. So we say, well, there are 2 red marbles out of 6 total marbles. Alright, now I just have to plug it back into my formula. So the probability of getting a black and then getting a red is the probability of getting a black, which was 4 out of 6, times the probability of getting a red, which is 2 out of 6. For multiplying fractions, you multiply straight across the numerators and denominators. So 4 times 2 is 8, 6 times 6 is 36, and you could either reduce this or you could type it into your calculator, which gives me 0.2222 repeating, so maybe say 223, or 22.3% chance of this happening. Great. And that's with replacement, because what we're saying actually happened here is that I have my big sack of marbles over here. First I chose a black. Notice maybe it was this black. I pulled it out. Then I was like, okay, this says with replacement. So that means that after I pull it out, before I choose the red, I put that black marble back in. So that means that the probability of getting a red was still 2 out of 6 because there were still 6 marbles because I put the black back in. And that's what the keywords with replacement mean. Now let's take a look at dependent event. And often we'll have the keyword without replacement. So looking at the formula for that, if I'm going to pick a black and then pick a red, the new formula, as we go up here, for dependent, says it's the probability of getting a black times the probability of getting a red, given that I pulled a black on the last trial. Okay, let's keep keep our marbles up there. So okay, so first I choose a black. Let's plug this in. We still have our probabilities over here. So the probability of a black was 4 out of 6. But now, I pulled this black, and this is without replacement, so I'm not putting that black marble back in. So the probability is going to change. This is not the same as the probability of just pulling a red. This is pulling a red given I chose a black, but it's pretty simple. All I do is say, well, I still have 2 red marbles, but now the total is out of 5 marbles. And that's why it's changed. And that's why these are dependent events. The probability of choosing a red depends on what happened in the first trial. In the first event, I picked a black. Now, I'm picking a red. This is still considered one event, pulling a black and then pulling a red, but it's kind of on the basis of you doing one thing first and then doing the other thing second. Completing this problem, we multiply straight across. 6 times 5 is 30, and then you could reduce, or you could just throw it into your calculator and get that as a decimal, which gives us 0.26666, repeating, so I'll say 267, which is the same as 26.7%. And so you could even compare that these probabilities are different, and that we have a higher percent chance of pulling a black and then pulling a red than we do of pulling when we don't replace the black marble, versus when we do replace the black marble, we have a less chance of pulling a black and then a red. And you could ask yourself why that's actually true. Well, in the original problem, we had 4 black marbles and 2 red marbles. So when we replaced the black marble for the independent events example, there were a lot more black marbles and a less of a chance of pulling that red marble in the second attempt. Whereas in the dependent events problem, without replacement, when we pulled that black marble, there were now 3 black marbles to 2 red marbles. So it was a little bit more probable that we could pick that red marble that second try. For independent events, what happens in the first event has no effect on the second event. So when we replaced the marble, it was as if nothing changed, meaning none of my probabilities changed. But for dependent events, what happened in the first event had an effect on the second event. So that's why without replacement, that second event is now going to be impacted, because for this example, we pulled a marble, which means that the probability changed for that second event.